Welcome back, everyone. In this lecture, we're going to do a quick overview of the time series exercise, and in the next lecture, we'll go along with a solutions video. So let's hop over to your Recurrent Neural Networks folder and show you how you can get the exercise notebook. All right, so under the Recurrent Neural Networks folder, you should see a file called timeseries.ipynb, so that's our notebook file, as well as a solutions file for the time series exercise. And if you scroll down, you'll also notice that there's a monthly milk production CSV file in that same folder. That's the file we're actually going to be using. So when you click on that exercise notebook, you should get something that looks like this, the time series exercise. And as always, all you really have to do is follow along with the instructions in bold. And if you ever get stuck on something, just go ahead and watch the solutions video where you'll get an explanation with a code along lecture. What we're going to be doing is trying to create a recurrent neural network model that is able to basically successfully predict monthly milk production based off a real data set. So here's a link to the actual data set. Remember, it's already been downloaded for you, but in case you want to know the source, you can click on that link. It's basically just milk production per month in units of pounds per cow from January 1962 to December 1975. Again, this is an older data set, but the reason I really like using it is because as you scroll down, once you'll eventually plot it out, you'll notice that it's a pretty obvious visual trend here. So we get this upwards trend, and there's definitely a seasonality to it. So hopefully it should be really obvious whether or not your network is doing a good job of generating a time series for it. So what you're going to end up doing here, you do the usual import pandas, matplotlib, use pandas to read in the CSV file, check out the head of the data frame. You'll notice here that this is actually still not a date time index. So you're going to convert it to a date time index by using this following command. And then from there, you'll be able to easily plot out this milk production plot. Once you've formatted the data correctly, the next step is to perform a train test split. So we're going to attempt to predict a year's worth of data, so 12 months or 12 steps into the future. In order to successfully do a train test split, you're not going to be doing a random train test split, because for a time series analysis, that doesn't really convey what you're trying to actually accomplish. What we want to do is feed in everything into our network except the last year of training data. And then when we actually test our network, we're going to test it against that last year and see how well our network can predict the year we do know versus the actual prediction cycle. So again, what we're going to do is take all the data except for that very last year and treat that as our training set. And then this last 12 months of data, that's going to be our test set to see how well our model can actually create one of these cycles as a prediction. And then hopefully, if it performs well, then we'd be able to use it for further years like 1976 or 1977, etc. Now, there's definitely a limit to how far into the future you can accurately predict, but for now, we'll use this last month of test data that we do know as our basically evaluation. So you're going to perform a test train split. Again, you're going to do this using indexing, not using random train test split. So follow the instructions here. The last 12 months of data, that's going to be the test set. Everything else is for training. Then we're going to scale the data. We didn't have to do that in the previous lectures because we were just using sine of x. But in this case, since this is real data, we should use some pre-processing to do the min-max scalar on it. And remember, you're only going to do fit transform on the training data and then transform the test data. You shouldn't also fit on the test data, otherwise you're assuming you would know about future behavior. So again, really important points here. The train test split is different than what you're typically doing because it's time series, as well as the fit transform. Then you're going to create a batch function. So you're going to need a function that's going to feed batches of training data. So you're going to need to do several things. You're going to need to follow these steps, step 1, step 2, and step 3. And if this is pretty hard for you, you can feel free to reference the solutions, but this is heavily based off of what we just did in the previous lectures, so you can use those as references for you. And there's essentially instructions here for you to follow for each of these 3 steps. So you're going to create a function that basically takes in that training data, takes in a batch size, takes in a number of steps, and feeds it back out. Then you're going to set up your RNN model, so you'll import TensorFlow. You're going to have constants, so you can define these constants in a cell. I have things like the learning rate already laid out for you, number of neurons, and the number of iterations for training, etc. But again, these are the ones I used in my solution. You can definitely play around with some of these values. it isn't to say that this learning rate is the learning rate you should use. You should definitely play around, see if larger or smaller learning rates work better for this particular data set. And again, it's also going to depend on what type of cells you decide to eventually use. Then you'll go ahead and create placeholders for X and Y, and then you'll create the recurrent neural network layer or your cell layer. You really have complete freedom over this. I really want you to explore and play around with what works well, but if you're ever in doubt, keep in mind the solutions, you can just use something like an output projection wrapper around a basic LSTM cell or even a basic gated recurrent unit cell. So if you're in doubt of what combinations you should use, just try out an output projection wrapper around the basic LSTM cell with a rectified linear unit activation function. Then you're going to pass those cells into this tf.nn dynamic RNN and along with your first placeholder x, just like we did in the previous lectures. You're going to create the mean squared error loss function, use it to minimize the atom optimizer. Then you're going to initialize global variables, create an instance of tf.trainSaver so you can save your actual model, and then you're going to run a session that trains it, and hopefully once you're done training it, what you're going to do is predict the future. So remember, your test set is the last 12 months of original data that your model has never seen before. So you're going to perform a generation session that's going to allow you to try to predict those last 12 months of data. And eventually, what you should end up doing after following these instructions is get something that looks like this. Milk production, that's the real stuff, and then the generated values. So you should get something that's pretty well aligned with the actual milk production. You can see we are off, but the general behavior and trends seem to be pretty darn close. Okay, so this is a pretty challenging exercise, so always feel free to jump to the solutions lecture in case you get stuck anywhere. And like I mentioned, play around with the units, play around with the training steps, play around with the learning rate. That's really half of the fun here. Okay, thanks everyone, and I will see you at the next lecture where we go through the solutions.